Hello everyone, and welcome to Leetcode PCD for the contest 459, weekly contest 459. Uh, can someone quickly drop in the chat if I'm audible? I guess I'm audible, I'm assuming that. Anyways, let's get into the problems. But before that, I'd like to inform you that our self-paced courses, TL Eliminators self-paced courses are out right now. They're on a sale, right? So do check them out. If this is your first time interacting with like TLE Eliminators, then this is the first time you're seeing our self-paced courses. These are self-paced courses in competitive programming, which take you through every level of competitive programming, whether you're an absolute beginner who could solve only maybe one or two problems in today's lead code round, or if you're able to solve three problems and you want to up your level and solve all four problems, then some level has some, like each level has something for you, right? There's more than 40 hours of recorded lectures, more than 100 curated practice problems, hints and video solutions, as well as doubt support and a leaderboard. So do check it out. Go to telimiters.com/courses. Okay. All right. How was the round, guys? Good, bad, okay. How many questions did you get? First question, I think definitely everyone would have gotten. What about B, C, D? Two. Okay. Arpan says two questions. All right. Two questions. Okay. Looks like most people seem to have gotten two questions. Um, Trapezoids. You got the trapezoids question, D or B? There were two trapezoid questions. Anyways, let's get right into it. Problem A, we won't spend too much time. Let's just quickly read the problem and solve it. So we are given a positive integer n. Determine whether n is divisible by sum of the following two values. The first value is digit sum of n, which is the sum of digits. The second one is digit product of n, which is the product of digits. Return true if n is divisible by this sum, otherwise return false. Okay, so we simply need to find digit sum, digit product, find the sum of these two values, and check if n is divisible by this or not, right? And n goes up to 10 power 6. So nothing much to think here. In fact, we can just directly simulate the problem, right? Problem A, solution. I'll directly write the solution. Directly simulate the statement. Directly simulate the problem statement. Okay. If you're having trouble with this, then I believe you should learn some programming languages more, right? You should practice C++ or Python or whatever programming language you're doing right now, or you can take TLE level 1 course. Okay. So let's have a look at the code. We find the sum and product. So initially sum is set to 0 and product is set to 1 because those are the default values for sum and product, right? Then here I'm creating a temporary variable to store the value of n because I'm finding the digits, right? I'm finding the digits of n, and this is one way to find the digits. And basically I'm taking n mod 10 to find the current digit. I'm adding that to the sum and I'm adding that to the product. Then I'm dividing by 10. So that digit gets reduced. Then finally I'm returning if n mod sum plus product is 0. That will be true or false based on whether uh, n is divisible by sum plus product or not, right? So that's all. Yeah, you can also convert to string and do it. In Curgio, yeah, good morning, good morning. So yeah, you can convert to string and you can do it, yeah, that also works. Okay, so that's all for problem A. Any idea when the next live batch starts? I'm not sure. I'm not 100% sure, but I can ask and get back to you, I guess. I'm not fully sure when the next live batch will start. Okay, so that's the first question. Let's move on, right? It's not that much interesting. Okay, problem B. And for this, you need to know some basic geometry for problem B and D, both. Okay, so in problem B, you're given a 2D array points where points of I is xi, yi. So you're basically given some n points in the Cartesian plane. Okay, they're integer points, by the way. Now it's going to define a horizontal trapezoid is a convex quadrilateral. Okay, so what does convex quadrilateral mean? It means it's basically a quadrilateral. It has four sides, right? It has four sides, and Maybe it has some properties on those four sides, right? And basically what it's saying is it's a convex quadrilateral with at least one pair of horizontal sides. Okay, so it has one pair of horizontal sides which are parallel to the x-axis. Fine. Two lines are parallel if and only if they have the same slope. Return the number of unique horizontal trapezoids that can be formed. Okay, so basically you're given some endpoints. Let's say in a plane you're given some endpoints. I'll just pick out some endpoints, right? And then you need to find how many of these trapezoids you can form, right? So one trapezoid I can form is this one, and this is a horizontal trapezoid since it's parallel to the x-axis. Fine. So assume that this is the x-axis. I need to find the horizontal trapezoids which are having these sides which are parallel to the x-axis. Okay. Since the answer may be very large, return it modulo 10 to the power 9 plus 7. Okay. What are the constraints? The total number of points can be at most 10 to the power 5. So n can be at most 10 to the power 5. And the coordinates of the points can be anywhere between 10 power negative 8, negative 10 to the power 8 to 10 power 8. And all the points are distinct points. Okay. You can also look at the examples to see like they've given a bunch of points and they're showing you what is classified as a horizontal trapezoid, right? So this is also a horizontal trapezoid because here this is parallel to this and there are four sides and this one is parallel to the x-axis. So that's why that's a horizontal trapezoid, right? Okay, so now how do we approach this problem? Well, it is a simple geometry plus counting. So if you got stuck in this during the contest, you need to learn some basic math and basic combinatorics. Okay. Those are the topics you need to focus on if this problem caused you some trouble. Okay, let's see how to approach it. It's mostly implementation. There's not much problem in this. So here's the intuition. Okay, intuition. Group points x y. So each point is like xi yi, right? By their y coordinate. Okay, by their y coordinate. And what do I mean by this? Basically, if I have given a set of points, and let's say these points are like this, and there are some points here, and let's say some points here. Okay, here y equals, let's say 1, here y equals, let's say 3, here y equals, let's say 6. Okay, and obviously there'll be at most some number of y coordinates, right? So all the points will fall on one of these y lines, you could say. So these are all lines parallel to the x-axis, right? If the y coordinate is fixed, these lines will be parallel to the x-axis. So now between any two of these, right, any 2 points over here and any 2 points over here, if I take these two and form 2 lines, then these 2 lines will be parallel to the x-axis. Okay, these lines will be parallel to x-axis. Fine. Between any of these 2 points in this group, in the same group, the line formed will be parallel to the x-axis. Okay, so between any 2 points in the same group, the lines formed will be parallel to x-axis. Okay, does that make sense? If this not making sense, someone put in the chat. Otherwise, I'll continue. I'm assuming that this made sense. Okay, so between any 2 points in the same group, what is the group? Group means they have the same y value. Okay, then the lines formed will be parallel to x-axis between any of 2 of these points. For example, right, then you should practice PNC. Anyways, so between any 2 of these points, if you form a line, since the y value is the same, it will be parallel to the x-axis. Okay, so now let us do one thing. Let us find how many total such lines there are in each group. Okay, so basically any 2 different pairs will form a different line, which is at this y value and which is parallel to x-axis, right? So for example, since here there are 4 points, we can form 1, 2, 3, 4, 5, 6. 6 total pairs of lines, all of them at this level, which will be parallel to the x-axis, right? So total number of lines will be, you can show by PNC, it will be n choose 2 or n times n minus 1 by 2. Okay, we can also write this as n choose 2. Okay, so that is the total number of lines in this group, which we can form parallel to the x-axis. Okay, time complexity of my solution will be n log n, I think, for B. Anyways, so this is the formula to pick 2 points in one y coordinate. Okay, so 2 points in one y group. Okay, so now let's say we know how many are there. So let's say these were our set of points. Okay, so in this y group, they can be total 6. In this y group, they can be total 3 times 2, so that'll be 3. And in this y group, they can be 1. Okay, why 1? Because it's 2 times 1 divided by 2, which means 2 choose 2. There's only one possible way to form a line. Here there'll be 3. So this is 1, this is the other way, and this is the third way between these two, right? Now, how to form a trapeze, this parallel trapezoid thing? Yeah, you can do often if you like, but you need to group by y value, right? So yeah, you can do often using unordered maps. We are not taking, what do you mean auto xy? I didn't understand, Akash Srivastava. What do you mean by xy? Which part of the code are you talking about? To be honest, I'm not sure what either of you are talking about, Watermelon or Akash. I guess I'll finish explaining and then come back to your doubts. Okay. And you can have a look at the code and then we'll come back to your doubts. Okay. So now, let's say I have a line here, which is at some y coordinate, and I have another line here, let's say between these two, which is at a different y coordinate. Now, these lines can be anything, but we have that this is parallel to this, right? This one will be parallel to this, will be parallel to this, right? This is the x-axis, right? So we found one trapezoid satisfying our conditions, right? Similarly, between any two pairs of lines, right? Between any two pairs of lines, we can form a valid trapezoid as long as those lines are from a different group, right? From the same y group, we cannot form a trapezoid because the area of the trapezoid will become 0. It won't be an actual trapezoid, right? So we can choose these two, we can choose these two, we can form a trapezoid. Similarly, we can choose these two, we can choose these two, we can form a trapezoid, right? And that's how it works. So what are the total number of trapezoids that can be formed in this case? Well, that is simple to write. So basically we need to choose one from this and one from some other value, right? So how many number of ways will that be? So let's say what we're going to do is first we'll choose the one on the top and then we'll choose the line on the bottom and then we'll find a trapezoid between them. So for the first line, the number of ways will be 1 times 3 plus 6. Now for the second y coordinate group, the number of ways will be 3 because there are 3 possible ways to do it. And to choose the bottom line will be 6 ways. And for the final group, there'll be 6 times 0. Okay. So the final answer will be 1 times 9 plus 3 times 6. So for this given example test case, which I've drawn over here, the answer will be 9 plus 18 or a total of 27 ways. Okay. Why is it 27 ways? Because I'm saying that, okay, first we'll choose the top line from this group. That can be done in one way, right? Then after that, I'll choose the other line from some group below it. So that can be done in 3 plus 6 total ways. So it'll be like this, right? So what will be a general formula? General formula for each y group or same value of y coordinate, that's what that means. Sum n choose 2 plus m choose 2 plus the sum of m choose 2 for all m smaller than this, right? For uh, m in y group below the current one, something like that, the formula will be. Okay, if you want to write it mathematically, but this is the intuition. Basically, we're saying we'll first choose the top line and then we'll choose the bottom line. So how many ways there are? So if the top line is at y equals 6 line, if it's in the y equals 6 line, then to choose the top line is one way, then multiplied with 3 plus 6 to choose the bottom line. Similarly, if the top line is y equals 3, then there's 3 ways to choose that, plus 6 ways to choose the bottom line. Right, because the bottom line has to be below the top line. Similarly, here there's 6 ways to choose the top line, but 0 ways to choose the bottom line. So that's why it's 6 times 0. So this is what the sum comes out. And then this is the total number of ways using this formula. Okay. Does that make sense? We can do a plus b whole square. Okay, maybe there's a linear solution in that way. I'm not sure about it. I think this is the more direct and straightforward approach to the problem. Okay. So let's see how to implement this. Pseudocode. Okay. If you use unordered maps in my idea, although that might be like maps, unordered maps can be hacked, so I don't recommend it, right? But if you use unordered maps in my idea, then you can do it also in linear time, average linear time, right? But yeah, so what we're going to do is to group by y value, to group by y value, we'll make a map, we'll make a map which will count for every value of y, for every value of y, how many x coordinates are there? Okay, how many x coordinates are there? Okay, this is the first step. And then what will we do? So basically we have map of y equals count of these x coordinates. Okay, the specific value of the x coordinate does not matter, as you can see. So count of x coords, right? This is what our map will store. Now what we need to do is we need to find the number of lines, right? So lines will be two pairs of points. So basically every map of y, it should be transformed into this value. So let's say there were n x coordinates, so it should become n times n minus 1 by 2. So we need to store this value. Then for every pair yx in map, right? What should we do? Now what we should do is basically we need to count how many ways this particular group can be paired, right? So this particular group can be paired with the number of lines in the current group plus the number of lines in the group which came before. So we can write that as answer is equal to so number of lines in the current group is simply x, you could say, times the number of lines in the previous group. So let's call that some total. Okay. In the start, total is equal to 0, and answer will also be equal to 0 in the start of this loop. And then after we add this, we can also add the current count to total. Okay. And then finally, we can print the answer. Okay. So because I'm using map, this solution is n log n. If you use unordered map, you can run the same solution big O of n. Okay. There may be some alternate solution which can solve this in O of n deterministically as well, but I'm not sure about that right now. Okay. Right. So time complexity, big O of n log n. Okay. With maps. Also, please note, use modulo at each step, right? Here I've not written in the pseudocode, but since the answer is required with modulo, use mod at each step. Okay. So that's the important thing. If you miss that, you will get wrong answer and you'll be stuck for a while thinking what went wrong. Okay. Let's have a look at the code. So I have a map from int to long long. Why did I keep long long? Simply because I don't want overflows. Okay. Um, for each point, I increase, see, points I of 1 means the y coordinate, right? So I increase the count of that. There is some x coordinate at this y coordinate, so I increase that count in this map. Okay. Now for each value in the map, basically what I'm doing is I'm trying to, instead of having the number of points, I'm trying to have the number of lines, right? So that is y times y minus 1 by 2. Okay. And here I'm taking modulo just to make it in the limits. Now I can pair some lines with all the lines below. So I said answer equals 0, total equals 0, same as I wrote in the pseudocode. Answer increases by y times total, because to make a pair over here, I can choose one line from this set and one line from all the lines below it. So that's why y into total. I increase my answer by that much. Then I increase my total by this much, and I finally return the answer. Okay. Please do a PCD for bike weekly too. To be honest, yesterday there was code forces around, right? So I could not do bi-weekly PCD. And like bi-weekly PCD usually clashes with something, so it's hard for me to do that. Okay. How are we calculating ans and tot? Okay. So you must understand what ans means. Okay. Uh, so what ans means is basically it's the final answer, which is the number of trapezoids formed. Okay. Number of trapezoids formed. Okay. And tot is number of lines parallel to x-axis, parallel to x-axis below the current y coordinate. Okay, below the current y coordinate. Okay, so for example, let me draw out. Now let's say at y equals 1, y equals 2, y equals 3. I have some points. Let's say I have 5 points here. I have 3 points here and 4 points here. Okay, where exactly the points are, they don't matter. Since if I choose 2 points here, 2 points here, they form a line. So between these two lines, if I draw 2 extra lines, it will always form a trapezoid. Okay, it will always form a trapezoid parallel to the x-axis. Fine. So I hope that much is clear. Okay. So now I want you to ask yourself, how many total lines are there in each y group? Okay. Yeah, I will take general doubts in the end. How many total lines are there in each y group? This question is for, who asked this? Aditya Singh. Yeah. How many total lines are there in each y group? Can you tell me that? Aditya Singh. So in this, in the last group, if you see there's 1, 2, 3, 4. So I can group these, I can join these points for 4 lines, right? And then here I can join the points for 3 lines. So basically, it's like the sum of n plus, is the sum of n minus 1 plus n minus 2 plus so on. Or in other words, it is the same as n choose 2, which can also be written with the simple formula n times n minus 1 divided by 2. Yeah. So here also it will be n times n minus 1 divided by 2. Here also it will be n times n minus 1 divided by 2. Okay. So that's what I'm also doing in my code. Okay. So first I'm finding the counts of each point at y-axis. Then I'm using this formula n times n minus 1 by 2. Basically, the map goes from y coordinate to the n. Okay. So here it's written as xy, but it's actually y coordinate to the n. So for each y coordinate, I'm finding the number of lines. Okay. So in this example, here there'll be 6, right? Here there'll be 6, here there'll be 3, and here there'll be 10. Okay. Now I need to find how many pairing of lines I can make such that they are in different groups. Okay. Now I need to find how many pair of lines such that they are in different groups. They are different groups. Okay, so that's going to be my goal. Okay, so how do I try to achieve this? Um, okay, so if you see these 6 lines which can be formed over here, okay, there are 6 lines which can be formed over here. They can be paired either with this or this. Yeah, does that make sense? Similarly, these 3 lines, they can be paired only with the 10 lines below them. And these 10 lines don't have anything below, so they can't be paired with anything below. Okay, so what I'm going to do is, in my start, my answer is 0. Okay, and my total is equal to 0. Okay, now I go to y equals 1. Now in my map, I'm doing iteration in my map, right? So I have y and n values from my map, right? So I go to y equals 1. And what happens to my answer? My answer becomes 10 times 0, which is 0 itself, right? And my total becomes 10. Okay, so now my total has become 10. So basically what I'm saying, my answer increased by 0 because there's 0 points below this to 0 lines below this to match. But now I'm going to increase my total by 10 because when I go to the next step, these 10 lines can be used, right? So now at this stage, my answer is 0 and my total becomes 10. Okay, so at y equals 1, my answer will be 0 and my total will be equal to 10. Okay, now what about at y equals 2? Now when I go here, currently my total is 10. That means there are 10 lines below me, right? And also there are 3 lines in my current set. So my answer will increase by 3 times 10. Okay, my answer increases by 3 times 10. So my answer becomes 30 now. Okay, my answer becomes 30 and my total remains 10. Okay, does that make sense? Sorry, my total becomes 13 because now there were 10 lines and now there are 3 more lines. So when we go to 6, we can say that there are 13 lines in below. Okay, are you following Aditya Singh? Now when I'm at y equals 3, my answer is 30. Now it becomes 30 plus 13 times 6 because there are 13 lines below and 6 lines on the top. So it becomes 30 plus 13 times 6, right? And that will be my final answer. And my total has increased to 19 because there are 19 total lines formed. Okay. Yeah. So, excuse me. Okay. Yeah. Now let's move to the fourth question now. Sorry, third question now. So I hope everyone understood the second question. Yeah. Okay. So there are multiple approaches to this. I'll tell 2 or 3 of them. Okay. I'll, I'll tell 2 or 3 of them. So you're given an integer array nums, and for any positive integer x, define the following sequence. Okay. P of 0 equals x, and P of I plus 1 equals the pop count of P of I. This sequence will eventually reach the value 1. Okay. The pop count depth of x is the smallest integer such that P of D equals 1. Fine. So it's defined a bit complicated. But basically what pop count depth means, if we repeatedly take pop count, how many times it will take to reach 1. Okay. So they have given an example. If x is 7, then 7 becomes 3, 3 becomes 2, and 2 becomes 1. So the pop count depth is 3, since this took 3 steps. Now what else? You're given a 2D array queries, where queries of I is either 1 LRK, which means the number of indices between L and R you should find, such that the pop count depth is exactly equal to K. And the second thing, update nums of I to val. Okay, update nums of I to val. So basically we should change one specific value in the array. Okay, so let me just explain the question quickly. So basically you have a bunch of elements, nums, okay, and let's say, let's call the array A itself because that's simple to work with. And we have A1, A2, we have A1, A2, A3 all the way till AN, right? So let's say there are 8 elements, right? Now what are our queries? The type 1 query says that between L and R, so let's say this is L equals 2, R equals 5. Between L and R, how many elements have pop count equal to K? Okay, how many have pop count equal to K? Okay, so that's the first type of query. And the second type of query is basically um, take a given element and change its value. Okay, so we can change it to some other value. So if this was maybe 7, we could have changed it to 10 or something like that. And so that will affect the values of the queries, right? So if this was 7 and now it's 10, so later doing a query on this range might give you some other answer. Okay, so I hope this part is understandable. Right. So how to approach this problem? Well, first we need to explore Popcount-Depth. Okay. Observe what Popcount-Depth Popcount-Depth is. Okay. Let's take a number like maybe 257. Okay. What is 257? It is 2 to the power 8 plus 1, right? It's 2 to the power 8 plus 1, right? 256 plus 1 is 257. So we can say that it will be 1 followed by 8 zeros, right? So um, right, so this will be the binary representation. But even if we have 257, quickly the pop count will become very small. So the pop count of this is 2. So it will simply be 1 0 now, and then it will become 1. So the pop count depth of 257, let's call this PD, pop count depth. So pop count depth of 257 is simply 2. So even for large numbers, the pop count depth remains a bit small, and you can see this if you try many numbers out, right? And so we'll try to estimate how large pop count depth can be. How large can it be? Okay, that's what we're going to try to figure out. How large can pop count depth be? So for a given number, let's say a given number has 10 bits. Okay, let's say it has 10 bits. Then at most the pop count depth will be 10, correct? So basically we can say that the pop count depth of some n is less than equal to ceiling of log 2n, right? Is this correct? We can say that pop count depth of n will be less than equal to. Do we need sec tree? You can do it with sec tree, or you can do it with Fenwick tree, or you can do it with ordered set. So any three methods will work. Okay, but we'll get to that part. So how large can it be? It will be less than or equal to log 2 of n. Okay, the way I did it was with ordered set, but I will show you a segment tree solution as well. Okay, so the pop count depth will be less than equal to log 2 of n ceiling. Okay, so what happens if we repeatedly do pop count depth? Right, we need to repeatedly do until it becomes 1. Right, so this will be less than log 2 of n, log 2 of n, something like this, right? Roughly. Right, and so on the pattern will continue. Right, do you get me? So let us try and see on Desmos what happens to this. Okay, Desmos or any calculator you want. I'm going to use Desmos because it's simple, right? Let me just write. And what is the maximum value we can have? The maximum value of any number, any value is 10 to the power 15. Okay, so the maximum value is 10 to the power 15. So that's what I'll put here. Okay, so in one step you can see there will be at most 50. At one step itself, doing pop count depth, like doing one pop count will make the number between 50. Okay, so now let's do this again, but for 50. Okay, for 50. Now you see in two steps it has become 6. So it's a very fast decreasing function. Okay, now let's try 6, and now you see it become 3. And now if you try 3, it becomes 2. Try 2 and it becomes 1. So you can see using the pop count thing, using only 5 steps, we have made sure that it has become equal to 1. Okay, basically. So what we can say here is that for for any n less than or equal to 10 to the power 15, at most 5 steps, this should be pop count, okay, not pop count depth. Should be pop count over here. Okay. At most 5 steps of repeated pop count will make the number equal to 1. Okay. So basically max pop count depth is equal to 5. Okay. So basically the possible values of pop count depth are 0, 1, 2, 3, 4, 5. Okay. You don't need until 50, by the way. You need only up to 5. And I'll tell you why you need 5. Because um you can also, okay, yeah, you can pre-compute depths up to 50, but there's no reason, right? All you need to do is implement directly. So the way I implemented pop count depth was using this function, int pop depth. If x equal to 1, return 0. Otherwise, return 1 plus pop count depth of pop count of x. Okay, so this is how you can implement the pop count depth function for yourself, right? How to implement pop count depth function, which will calculate for some given number. What is the pop count depth in C++, right? And in any language, it will be very similar. Okay, you just need whatever function for pop count over here, this part, right? That's it. And this will take at most 5 steps. At most five recursion steps, right? At most 5 steps to give the answer. And the answer will be at most 5. Right? Answer will also be at most 5. Yeah. Okay. So now that we know how to find for some number what is the pop count depth, what was our question again? Our question was basically either we change a number, right? Either we can change a number. So that is query type 2, query type 2. And the second part of the question was query type 1 was in range LNR, in range L less than J equals to less than R, find count of pop count depth of J equals to K. Okay, so basically you're given L, R, K in the question, in the query, and you need to find how many are there in the pop count depth equal to K in this range LNR, right? So that's our query type 1. So how to approach this? So there are many approaches. I will tell you 2 or 3 of them. Okay. Now my first approach will be using the data structure called ordered set. Okay, ordered set. First approach, using data structure, data structure, ordered set. Okay, ordered set. So if this is the first time you're encountering ordered set, you can Google it. There's nice articles on what ordered set does. Okay, what is the fastest between merge sort tree, sec tree, bit, ordered tree? I think bit will be fastest. If you want strictly fastest, most probably bit should be fastest, since it has the least amount of overhead, I think. But don't quote me, okay? They'll all be very similar. But yeah, sec trees are usually slow because they use more they use more heavy updates and stuff, right? So it depends. And maybe because ordered set is already implemented in like PBDS, right? Yeah, like you said, PBDS. So maybe it's already optimized to be fast. So I'm not sure. You can compare. You can try both and compare. Okay. So I'll just show you like a resource for ordered set. Um, so if you just Google ordered set, you will get a bunch of resources. But like if you go to ordered set core forces, there was a article which just shows you like the basic examples and uses of ordered set. Okay. It's a policy based data structure, right? So you need some headers. If you include those headers, then you can use it. And here are some functions. So you can insert like a regular set. But the new things in this are find by order and order of key. Okay, so that is the new two main functions of ordered set. So, okay, interestingly, there are some statistics also of how much time it's taken to solve some problems using the different types of methods, ordered set versus segment tree versus binary index tree. And let's see, my guess was that binary index tree would be fastest. And yeah, we can also see that here. Binary index tree is usually faster since it's a smaller data structure than both of them. Right. But ordered set is easier to use. You don't need to, unless you don't have a binary index tree template, in that case. Can we use ordered set in interviews? Depends. They might ask you to use binary index tree or segment tree. And yeah, probably you must remember the syntax for it also. You're 1400 on CF, then I think you should learn. So first, obviously, you need the basic concepts like dynamic programming, graphs, disjoint set union, right? The main data structures you need to focus on are disjoint set union and segment tree. The reason we tell people to learn segment tree is because it can solve a wide variety of problems. Okay, it can solve problems which ordered set can solve. It can solve problems which Fedwick tree can solve. So even if it's a bit slower, it can solve all these wide variety of problems. That's why segment tree is like the best data structure to learn because it's so versatile. But yeah, the data structures main ones you should learn is segment tree, DSU, and ordered set. Okay, so learn these three, Arpan. Okay, so yeah, what does ordered set do? Let me just give you a brief summary. Very similar to set, very similar to set in C++. Okay. For people who are using Python and Java, please check if you have some similar data structure, or otherwise you can write a Fenwick tree or segment tree. Okay. Very similar to set in C++, allows a method called find by order. Okay, find by order key, which returns basically does like a binary search type of thing on the tree, which returns number of elements less than key. Okay, so find by order of key returns the number of elements less than key. Okay, now how will this help us solve our problem? Well, in our problem, we already know that the max pop count depth is 5. Okay, so what we're going to do is for each pop count depth between 0 and 5, between 0 and 5, we have a different ordered set. Okay, different ordered set which stores counts of which stores the counts of which stores the counts of the indices indices which have that pop count or which have that pop count depth which have that pop count depth. Okay, so what do I mean by this? Let's say our array was 3, 4, 5, 6, 8, 9, 7. Okay, let's find the pop count depth for this. So what is the pop count depth for 3? 3 becomes 2, 2 becomes 1, that's 2. 4 becomes 2, and then 2 becomes 1, that's also 2. What does 5 become? 5 becomes 2, that becomes 1, that's also 2. Okay, what about 6? Uh, so 6 is how many bits? So 6 becomes 2. Okay, that's also 2. Damn. Then popcorn depth for 8 is it's 1. There's exactly 1 bit, right? So 8 is written like this, so it becomes 1 in 1 step. So the pop count depth is 1 over here. What about 9? Again, the pop count depth will become 2. What about 7? 7 becomes 3, then 3 becomes 2, then 2 becomes 1. So pop count depth will be 4, okay? So the way our array will be, the way our ordered sets will be, there'll be ordered set for pop count depth 0. So let's call that OS 0, and that will have empty because there's no element with pop count 0, pop count depth 0. Now ordered set with pop count depth 1, and that will have the element. So the index are, this is the index, right? 0, 1, 2, 3, 4, 5, 6. So index 4 has pop count depth 1. So the ordered set of 1 will have 4 in it, okay? 4. Now what about ordered set of 2? Well, we can see that here, 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 and here, there is 2. So all the indices will be stored in the ordered set. So we will store 0, 1, 2, 3, and 5. Okay. Now what about the ordered set of 3? We can see that nothing over here has a pop count depth of 3, so that will be empty. What about the ordered set of 4? Wait, 7 becomes 3, which becomes 2, which becomes 1, correct? So 7 has a depth of 3. Sorry about that. It's just 7 has a pop count depth of 3, not 4. So yeah, the pop count depth of 3 will be for the 6th element. So that's 6. And this will be empty. And this will be empty. Okay. So we have these 6 total ordered sets for each different pop count depth, and they will store which index has that specific pop count depth. Okay. Now, what we can do is for query type 1, we are given LRK. Okay. And our answer will simply be, answer for this query will simply be ordered set K, and we can find by order using the, not find by order of key function, right? Order of key, which I told earlier what it means. It gives you the number of elements less than equal to the specific key. So we can find number of elements less than equal to, sorry, not less than equal to, less than the specific key. So that's why we're doing R plus 1. So all the elements up to R minus all the elements less than L. Okay. So this is how we use ordered set to solve the problem. And for query of type 2, simply we remove the old element from the ordered set and add the new element. Okay. So it will simply be I and value, right? So what we can say is ordered set of array of or nums of pop count depth. So let's call that PD of nums of I. So we erase this element I. Then we can set nums of I to the new value. Now we can again add whatever its pop count depth is. So we'll add it to the appropriate set, right? And we will insert key I. So that's all. This is how we solve query of type 2, and this is how we solve query of type 1. Okay, using the ordered set approach. Is this clear, guys? For 4 is 1. Okay, right, you're very right. Sorry. 4 will be 1 over here. My mistake. So how will the ordered sets change? Uh, so this is at position 1. So here it will become 1, comma 4. And here there'll be no 1. So it'll be something like this, right? So this will be our ordered sets. And the rest of the logic is the same. That was just the example, right? So this is how we find the queries in the ordered set. Okay. Ordered set of X holds an ordered set for a specific pop count. So for each of the pop count depth, I made a different ordered set. Okay. So the way this is defined is something like this. A vector of ordered set of size. So I don't know why I made it 10. That was just for safety, but it just needs to have total 6 from 0 to 5 ordered sets. So it's a vector of ordered sets. Okay. It's a vector of ordered sets, and it has an ordered set for each possible pop count depth. Okay. So that's what OS of X means. Okay, OS of X is simply an ordered set for the um, Popcount depth of X. Okay, and Popcount depth of X can only be 0, 1, 2, 3, or 5. That's why we need 6 of them. Fine. So we make these 6 ordered sets. Then for each number, we do V of Popcount depth of nums of I dot insert I. So we're just adding all of them to the appropriate ordered sets, the indices. Then here is our answer vector to store the answers to each query, right? Because that's how we have to give the output. Now for each query, we can, I'm finding the type of query. If it's type 1, I find LRK. I simply add ordered set K minus order of key R plus 1 minus order of key L, right? Otherwise, this is a change type query. I have to change the ith element to value. So this is how it's done. I erase the ith element, I change the value, and then I add that one to appropriate ordered set. And that's how we can handle all the queries, okay? Yeah, so segment tree also you can do it. How to do with segment tree? So this was the ordered set approach. Let's discuss the second approach with segment tree. Similarly, segment tree and Fenwick tree approach will be the exact same, right? Fenwick tree means binary index tree bit. So second approach, basically some data structure to have some queries, okay? Uh, any data structure which does point updates and range query for the sum, okay? So if you have some data structure which does these two operations, it can be segment tree, it can be binary index tree, etc. All those data structures. Segment tree is the most versatile one of them, so that one is the one you can assume to be used, okay? But if you want the fastest time complexity, binary index tree has like the fastest constant factors. Not time complexity, constant factor is very fast in binary index tree. Okay, so for this, what we will do, we will create 6 segment trees. Okay, 6 segment trees or binary index trees. Okay, which will be something like again v of 0, v of 1, v of 2, v of 3, v of 4, v of 5, v of 5, right? And what will they contain? Basically, the nodes of the segment tree, the leaf nodes of the segment tree, they will be 0 if the current position is not equal to the k, otherwise they will be 1. Okay, so if the current pop count depth is not equal to 0, it will be a 0, otherwise it will be a 1. Okay, so for our above example, this example, we can see the pop count depths are 2, 1, 2, 2, 1, 2, 3, right? And there are total how many elements? Total 7 elements, right? So the segment trees will look something like this: 0, 0, 0, 0, 0, 0, 0. Okay, and the second segment tree will look something like this. Yeah, so the second segment tree will be on at positions 1 and 4. It will be 0, 1, 0, 0, 1, 0, 0, right? And then the third segment tree will be on wherever the popcorn depth is 2. Okay, so popcorn depth is 2 at position 0, 2, 3, 5. So it will be here 2, 3, 5, right? So this will be the this seg tree, and this seg tree will look something like this, right? And the remaining 2 seg trees are all zeros because nothing has popcorn depth of 4, nothing has popcorn depth of 5. Fine. So this will have 6 different segment trees. Now, anytime we want to answer a query for some specific k, we can just find the range sum between L and R. So for example, if this was your L, this was your R, and we had to find how many have the popcorn depth equal to 2, then we simply need to sum over here. And because it's a 1 if it was popcorn depth 2, the sum will be the count. Okay. So that's how we solve this using segment tree or Fenwick tree. Which approach is most advised to use in interview? I will think the Fenwick tree approach is the best because it has the least constant factor. So that is the best approach maybe in the interview. But in online assessment, to save time, just use ordered set, okay? Akshit, you're asking for problem D. We will get to problem D very soon, okay? So let me just show you segment tree code because I had written that as well. So I have a segment tree template, which you don't need to worry about. You can just Google a segment tree template online, okay? So that I just added on the top. Now what happens to the main body of code we'll see. So here, instead of vector of ordered set, I have a vector of segment trees, okay? And the segment trees are initialized with empty vector of size n filled with all zeros. Then here I'm doing point update to 1 to mark that the element is of the specific popcorn depth. Similarly, point update of 0, point update of 1 is used here. And then my segment tree has the query function which will give you sum of L and R, right? So this is how you solve it with segment tree. This is the code. Okay. If you want, you can pause the video here and you can see how to solve it with segment tree. All right. And obviously you need some segment tree data structure. You can use a template. You can write your own template after learning, and it doesn't matter which way you implement it as long as you get the basic ideas right. Okay. Similarly, Fenwick tree. Any resource? I think Ericto's segment tree video was there. I think he had a segment tree video. That's where I learned from. Then to implement, I used like, a mix of online templates plus my own code. Okay, let's move on to problem D now with just a quick 1 minute break. Uh, and then we'll move on to problem D, okay? Okay, I'm back. Let's go on and move on with problem D. Yeah, Akshit will handle doubts and general doubts, specific doubts, what's wrong with your approach later. In fact, your approach is pretty similar, so maybe you'll understand when I explain the solution, okay? So just be patient. Okay, the question is like an extension of problem B. The question goes, you're given a 2D integer array points. By the way, for both approaches of problem C, the time complexity is big O of n log n, okay? For problem C, it's big O of n log n. Okay, I'm just telling for segment tree and binary index tree both. Okay, so moving on to problem D, right? You're given a 2D integer array of points in the Cartesian plane. Return the number of unique trapezoids formed by choosing any 4 distinct points. A trapezoid is a convex quadrilateral with at least one pair of parallel sides. And let's see the constraints. The number of points is up to 500, and the points can go up to 1000 till minus 1000. Okay, so number of points can go up to 500. So n is less than 500, right? Um, the points themselves can go like this, 1000 to minus 1000. Okay, the coordinate values. The second thing doesn't matter that much. First thing is the main thing, right? Okay, and what are trapezoids? They basically are, they have one pair of parallel sides, right? That makes sense. Okay, so let's discuss the intuition for this. Okay, intuition. Okay. So given a plane of coordinates, and let me just draw a plane with some coordinates on it. So we are given a plane and there's some coordinates on it, okay? Some points. Now I need to find out how many trapezoids I can make, right? So let's say I take a line like this, okay? This line, which has 2 points on it, okay? These 2 points. And I have another line, let's say there are 2 points here, okay? So I take another line and I draw like this, right? Then um, this shape has these two sides parallel, okay? This shape has these two sides parallel. And because two sides are parallel, are parallel. So that means that it is a trapezoid, okay? It is a trapezoid, okay? So what approach comes into your mind? And the main approach which comes into my mind from seeing the previous problem as well is that how many possible lines are there? Okay, because n goes up to 500, so we can theoretically check all possible lines, correct? So total number of lines that can be there, let's just write it here. The total number of lines, the total number of lines is at most the number of points squared, right? So that is less than or equal to n squared, so 2500, right? And second thing, if we take two parallel lines, if we choose any two parallel lines, any two parallel lines that are obviously non-intersecting, right? That are not at the same, like, that don't have the same x-intercept, basically, not on top of each other, basically, not on top of each other, then we can form a trapezoid, okay? We can form a trapezoid, okay? So basically, we need to find how many pairs of lines are there such that they are parallel, okay? So how will you mark this basically? So let's say there is these 2 points and then there's these 2 points, okay? And then the lines going through them are parallel. So one line going through them is like this. One line going through them is like this. Now, basically, the idea is since this is parallel to this line, the shape formed between these four will be a trapezoid, right? Because this is parallel and this is parallel. Does that make sense? Yeah. Now, what else do we need to keep in mind? Um, right. So why don't we just simply do the approach of finding all pairs of parallel lines, right? But we cannot check all pairs of lines, check all pairs of lines, because that will be n squared. Okay, that will be, sorry, it will be n squared squared, or n to the power 4. Okay, and that will be time limit exceeded if we manually checked uh all like n to the power of 4 combinations, right? So that should be obvious that this will be time limit exceeded, right? This will go to 10 to the power 10, which is too much for our problem, right? So we need to be clever about it. And so what is the idea over here? Let me just write it down. Core idea. Core idea. Again, it's similar to problem 2. The core idea is group lines by slope. Okay, group lines by their slope. Okay, so what we're going to do is we're going to have a map of slope which will contain the different lines of that slope. Okay, something like this, right? And what does that mean? So if we again had some points, over here, right? So then if this line had some specific slope, right? These 2 points had some specific slope, and then these 2 points had the same specific slope, right? Then we will have all of these in a specific map, okay? And what will this do? Basically, if two lines have same slope, lines have same slope, but different intercept, we can pair them together, okay? We can pair them together, okay? I hope that makes sense. So if they have the same slope and different intercept, we can pair them together. Is it visible now? I'll just scroll up so you can see what all I wrote. I wrote the total number of lines will be less than equal to n squared, so we can find all the lines. But we cannot find all pairs of lines because that will become n to the power 4. Then I wrote we're going to group lines by the slope, and we use this observation that if two lines have same slope but different intercept, we can pair them together and form a trapezoid, okay? And form a trapezoid, okay? All right. So basically what we're going to do is for all the lines formed, we'll do map of slope, and we can have a double map, okay? Slope and intercept in our map, or otherwise we can have a map to slope to intercept, but for our purpose, this will be better. Intercept plus plus, okay? So for this specific slope and this specific intercept, there is one more line, okay? And then what we need to do to solve the problem will be basically for each slope, again, we do the same sum and tot idea from before, okay? So sum equals 0, total equals 0. For each intercept with this slope, sum will be count times total, okay? And then total will increase by count, okay? And if you're not understanding this, just rewatch problem B, how we had solved it. Basically, in problem B, there was only one slope which is parallel to x-axis. But in this, there are not only one slope, it can be any slope, but this much logic remains the same. And basically what we're saying is we can pair any two of them together which have different intercepts, right? So for example, for some given slope, let's say this specific slope, there are some given points. Okay, so there's a point here, 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 similarly here, here, and here, similarly here and here. Okay, so basically this can be paired with um with either this line, this line, this line, right? Or this line, right? So all the counts of lines, let's say there were 2 lines here, 3 lines here, and we can basically say that this one line over here, one times, so let's say there was one line over here. So 1 times 4 plus 3 lines times 1 plus 1 line times 0, right? Basically, that's what we're doing. We're finding how many pairs we can form of the lines with different intercepts. Make sense? So this code is for finding number of pairs of lines, number of pair of line with different intercept, intercept and given slope, Okay. And you would think that this is just the answer, right? You would think that we have already gotten the answer, but actually there are some edge cases which we must consider and we'll get into. So like we can write the final answer as 0 outside of this whole loop. We can add sum to the answer at every slope, right? So for each slope, we are finding each possible pairing. We're summing that up, and then we're summing for all the slopes what is the possible answer, and we're printing that, right? But now the issue with this is one issue with this idea, okay? And what is the issue? Like this took me some time to find in the contest. The issue is that let's say we have this shape over here. Okay. Now, in this shape, these two lines are parallel. So we can say that we can form one trapezoid. So the answer becomes 1. Okay. But what happens is these two lines are also parallel. Okay. These two lines are also parallel and they also have um, different intercepts. So again, we do ans plus equal to 1. And what happens is our answer becomes 2. Okay. Our answer becomes 2. But actually, our answer should be only 1. Our answer should be only 1 because both of these slopes are forming the same shape itself, right? Both of these slopes are forming the same shape itself. And basically, the problem is parallelograms. Parallelograms. Parallelograms have two sides parallel, two sides parallel twice. Basically, for a parallelogram, we know the definition, right? Um, these two sides are parallel as well as these two sides being parallel. So what's happening when we're counting slope wise? The parallelograms are getting counted twice. Okay, getting counted twice. Does that make sense? Parallelogram are getting counted twice when we are doing the slope method of counting how many trapezoids are there. So instead of saying one trapezoid, it's saying two trapezoids because when it comes to the slope for the top and bottom lines, it will count it once. Then when it comes for the left and right lines, it will count it again. So this method was almost correct, but we must subtract the number of parallelograms from the answer. Okay, because each parallelogram has become counted twice. So our final answer equals number of is equal to answer minus number of parallelograms. Okay. So this much is understandable. I think the person who was asking a question, Akshit, you also did something like this. Get all trapezoids as we did in question 2. Double counts parallelograms. Okay. So I think there's an issue on your part which says that note that all parallelograms have equal side lengths of parallel sides. What do you mean by that? Because okay, the parallel sides are equal, but the non-parallel sides won't be equal. Okay, so remove all possible pairs having same length m. Okay, okay. So I think so. Basically, you need to be very careful while counting number of parallelograms. So maybe your approach works. I'll tell you my approach for how I did it. So you can just Google actually count number of parallelograms n squared. This is a well-known problem, I think, in a set of points. Yeah, there's a Geeks for Geeks article as well. So I'm not sure about Leetcode's rules. Codeforce's rules allow you to use Geeks for Geeks and other sources. But obviously, ideally, you should know the answer yourself, right? Um, yeah, there is a n squared log n solution given here. Right here, you can just count the number of parallelograms in a set of points, right? And the standard way to do it is to count the number of midpoints. Okay? The standard way to do it is to count the number of midpoints. Okay? So all you need to do is just take this function, okay, and plop it down into your code and subtract that, and that works. Okay? And the reason this approach works, the given approach here, is that um, if there are if there's a parallelogram, right? If there's a parallelogram, if there's a given parallelogram, and let's say we have these lines and these lines, like just give me a minute to explain this. So we have these two parallel lines, and we have a point, 2 points here, right? And this is how we're forming it. So basically, at a given um, set of points, right? The Yeah, so the logic was that the diagonals of the parallelogram intersect in the middle, right? So basically, what we need to do is we need to find the um we need to find the midpoint, which is basically, let's say this is x1, this is x2, right, for the given line. So if we take the average, we have this. Similarly, if we take the average of the y values, uh sorry, so basically for the parallelogram, we have 4 points, right? So assume this is P1 and this is P2, and we have a given midpoint. Okay, so this midpoint and this midpoint, they will coincide. Okay, these two midpoints, they coincide. And basically the way, so this is a standard problem. I also had Googled it during the contest. So the way you count parallelograms is basically count the number of midpoints, count the number of common midpoints. Okay, count the number of common midpoints in all pairs of points. Okay, and we can prove that this is the same as the number of parallelograms. Okay, and that's the whole idea for counting the number of parallel points. Basically, for every pair of points, we need to find the midpoint, right? And the number of midpoints which coincide, that is the total number of parallelograms. Okay, I hope that makes sense. So what we're going to do is basically we're going to have another map for each midpoint. Okay, for each midpoint, what is the count? Okay, and one more thing to keep in mind. So this is the final thing, is that the midpoint should also have the intercept as different. Okay, so the midpoint's intercept should be different. And what does that mean? Basically, if we have 4 points like this, okay, degenerate 4 points, um, which are all along a single line, right? Even then they will have the same midpoint, right? They will have the same midpoint, even if they're all in the along the same line. Sorry, their intercept, no, their slope should be different. Slope should be different. So for a given diagonal, if they are along the same line, then while the midpoint is same, they don't form a diagonal, right? So they don't form a parallelogram, so they should not be counted. So that's why we'll keep track of the slope as well. So let me just simplify and write the full approach again. Just a second. Like I had looked up this trick, so kind of not that much in memory right now. Okay. So the idea basically goes, given some 4 points, right? If these 2 points have a specific midpoint M, and these 2 points also have a specific midpoint M, if these two coincide, then we can say that the number of parallelograms is equal to the number of coinciding midpoints. Okay, so we just need to count how many pairs of midpoints are at the same position. Okay, so we'll have a map of midpoint, and each time we get a specific midpoint, we'll do map of midpoint plus plus. Okay, so that will keep track of how many midpoints coincide at a specific point, and we can add that much to our answer. One thing we should notice: what if the lines were something like this? Okay, what if we had 2 points like this? So like this, and these two's midpoint is also here. These two's midpoint is also here. These two's midpoint is also here only, right? But this is along the same line, so no parallelogram is formed since it's degenerate. No parallelogram, or we can say degenerate parallelogram. Degenerate. So in this case, we don't need to add. So we also need to keep track of slope. So we'll also have map of midpoint slope. Okay, so for each midpoint, what is the slope? And we need to keep track of that. So now what will be the total number of parallelograms? Total number of this was the approach I used in contest, but you can obviously just directly copy paste this geeks for geeks function and subtract that much amount. Like this is a standard problem which I've seen before as well. Is my screen not visible? Yeah, sorry about that. The cat does I do have a cat, yes. Okay, so the total number of points, yeah. The total number of points coinciding minus total number of points coinciding with the given slope. Okay, points with given slope. And this will be added to the number of parallelograms. Each time we find some coinciding thing, we can add this to number of parallelograms. Okay. And if you want to learn more about this approach, and like this was my approach during the contest, if you want to refine the approach, just read this Geeks for Geeks article, or there'll be many other articles which show you how to count the number of parallelograms in a plane. Okay. So that's how we do it. That's how we do it, right? Okay. So let me just summarize the approach, summary of the approach. And there's some technical details also for the approach. Summary. So the first thing we need to do is we need to group by slope. So map of slope. We also need to find their intercept. Okay. So for each pair of points, we find the slope and intercept and increase it. Okay. And then second thing we need to do is we need to pair them up for each slope. So for each slope, we keep track of so the intercepts must be different, right? So we do this code same as problem B. So we have that logic, basically sum and total logic. We need to find how many pairs of lines can be paired up which have the same slope but different intercept. So same logic as above, right? So now we'll get an answer. We'll get an answer which is basically number of trapezoids, but it will overcount parallelograms. Overcount parallelograms. Okay. And the way we find parallelograms, the standard way at least, is by checking the number of midpoints. And if two midpoints coincide, then they can be forming a parallelogram. So basically, subtract number of parallelograms. Subtract number of parallelograms. And since we have to go through all the points again, I had just done this in the starting loop itself, right? When I realized we had to subtract parallelograms, I did this in the starting loop itself, right? So what I basically kept track of was also, like while I'm keeping track of slope, for each midpoint, map of midpoint plus plus, and also map of midpoint and slope plus plus, okay? So now because we need to form pairs of points which have the same midpoint but different slope, so very similar logic. Basically what we can do is parallelogram count or something. Let's just call it parallelogram. Imagine that's a variable. So at each midpoint, it will increase by this amount. So how many other midpoints are there with the same value of midpoint but different value of slope? Okay. Yeah. So it's a pretty geometry and PNC heavy idea. It plus implementation is not that easy. So yeah, this is the full summary. And then once we subtract the number of parallelograms, we can return the answer. Okay. So this is the full idea. The parallelogram part, I'm not fully sure about Leetcode's rules, but I think it's allowed to use outside sources if they were pre-written, not AI generated, right? As long as they were pre-written, like a Geeks for Geeks article, since this is a very standard problem, which I think even in my course they taught how to count number of parallelograms in DSA 2, I think. So yeah, this is how we do counting number of parallelograms. Fine. Okay. So that's the full idea. What is the time complexity? Yeah, so one technical detail is how to store slopes. Okay. So for slopes, you need the slope formula, right? Slopes. The slope formula is y2 minus y1, x2 minus x1, or something like that, right? Yeah, y2 minus y1, x2 minus x1. And you can see that if you do this normally, it will become a double type, right? It will become a double type. But we don't want it to be a double type because that can lead to precision errors. Okay, if we store the exact slope, we can't even keep it in a map properly because it will lead to precision errors. Okay, so the way I was storing slopes was as a pair. Okay, fractions can be stored as pairs. of y2 minus y1, x2 minus x1. Okay, so that's how you can store the slopes as pairs of y2 minus y1, x2 minus x1. And you should remove all the common factors. So you can divide by g, which is the GCD. Okay, g is the GCD of y2 minus y1. So this is just to make it a proper fraction. Okay, so that's how I was storing the slopes. Fine, to avoid floats. Make sense? So that's the technical detail while finding the slope. Similarly, while finding the intercept, make sure not to use doubles anywhere because that causes problems. As for midpoint, since we're doing this, we're finding the midpoints of points x1 by x2 by 2, y1 by y2 by 2, right? So this will also again become floating point because we're dividing by 2. But we can avoid floating point simply by multiplying by 2. It doesn't matter. We just need to know whether they're equal or not, right? So these are all tricks to avoid floating point. Tricks to avoid doubles or floats. Okay. So we'll just multiply these by 2 so that they do not become doubles. Right. So instead of dividing by 2, we'll just keep x1 plus x2 and y1 plus y2. Since all we care is the count, we don't care about whether it's divided by 2 or not, right? We just want the count. Map of midpoint plus plus, map of midpoint slope plus plus. Okay. So now let's have a final look through the code for this. Do you code in Leetcode ID or local ID? So nowadays, I just directly code on Leetcode ID if it's simpler problems. But then if I get stuck or something, I copy to the local ID and then debug. That's what I'm doing. It's not a very structured approach. I switch between them. Like for example, problem C, I went to, because in problem C, I had gotten stuck somewhere, I'd made a bug, right? So then I went to a local ID and I tried both segment tree version and I tried the ordered set version. And then I managed to debug my code. I actually solved problem C last. Okay, let's have a quick look at the code for how to implement this. To make the slope into a pair, okay, it takes 2 points, x1, y1, x2, y2. It gives its slope as a pair. So there are some things to keep track of. Here I'm dividing by the GCD, like I said. So x1 minus x2, y1 minus y2, I'm storing as a pair. And I'm dividing by GCD. This is to make a proper fraction. What happens if x1 minus x2 is 0 or y1 minus y2 is 0, right? So in some places, the slope can be 0 or infinity. That doesn't matter. That means it's simply parallel to x-axis or parallel to y-axis. So I'm just storing it as 0, 1 or 1, 0. Okay. So that's just two special cases I handled separately. What is this? This is to make sure that basically, if I have a slope like -1, -2, right? So that will be -1 divided by -2, right? Which is basically the same as slope of 1 by 2. So if this is negative, and I'm trying to make that always x will be the positive one, and y can be negative or it can't be negative. So cases like this don't come up. So yeah, you should be careful while calculating your slopes in this pair form. So while storing fractions as pairs, these are the steps you need to take. If x was less than 0, I multiplied both sides by -1. Okay. So x will always be positive, dx will always be, dy can be positive or negative, doesn't matter. Now, if some value is 0, I can just return the two cases for the slopes. Otherwise, I'll make it into proper fraction form and return that pair of proper fraction. Okay. Next step, here is my main map. It's going to go from slopes to intercepts and count of the intercept. Okay, so it's a map from pair intent, which is the slope, to intercept, comma, the count. Okay. Now this is for calculating the parallelogram. This is for the midpoints. And this is the midpoints with the different slopes. So two maps, like I said. Okay. Okay. And this value int p gram, that is the number of parallelograms. It's going to count the number of parallelograms. Okay. So now this first part is just to count the map of slope intercept. Okay. So for each slope, each intercept, it will increase the map. It's finding the slope using this function over here. And intercept is finding using the intercept formula. You can go through it. right? You can just rewrite the intercept formula and you get it in this form using the slope. So that's all. Map of slope intercept plus plus. Now for parallelogram, this is the midpoint of x, mx midpoint of x, my midpoint of y. I'm not dividing by 2 because it's not needed. The count of parallelograms is increased by the number of points which have the same midpoint minus the number of points which have the same midpoint and same slope. Because if they have same midpoint and slope, they will not form parallelogram. That will be just a line. So that's why I'm finding the number of points with the same midpoint but different slope, and I'm adding that to the count of parallelograms. Then I'm increasing my count of midpoints with the current values, increasing the number of midpoints with slope. These two maps I'm updating. Okay. So once this loop is done, my first map is ready, the map of slopes and intercepts, and also my number of parallelograms will be counted. Okay. Now I'm calculating the answer. So for each slope and for each intercept within that slope, I'm doing this same thing which I did in problem B, which is basically for every line, I'm counting how many lines before it, below it, not below it here, but with intercept less than it, can be paired up with it to form a trapezoid. So that's what I'm doing here. And then finally, I'm increasing my answer with that. Now I already showed that this logic will overcount the parallelograms. So I subtract the number of parallelograms and then you can return the answer. Okay. So this is one way of implementing it. Obviously, I didn't need to implement the parallelogram here. I could have just directly copy pasted the Geeks for Geeks code, but then I was not sure if that is flagged or not. So yeah. So that's how we solve problem D. Okay. And what is the time complexity? Well, we have a bunch of maps and each map can store up to n squared elements, right? Total number of lines is n squared. So each map can store up n squared elements. So that total time complexity will be big O of time and memory both will be time complexity for this problem is big O of log or big O of n square log n square. And we know log n square is the same as log n. So it's big O of n square log n. For same reason, memory, because at most in the map we store each line. So the memory complexity is also big O of n square log n. Okay, so for this approach, and for n equals 500, this will definitely pass, right? We can just quickly check that up. N square log n, right? That's barely 10 to the power 5 operations. Okay, we have discussed all the problems. If there are any general doubts, you can ask it. Akshit, the way you were finding parallelograms, it does seem right on the surface, but maybe there is something wrong in your implementation. Maybe there's something wrong in the logic. So you're saying parallelograms have equal sides, remove all pairs having same length. But you know what the problem with your logic is, Akshit? There can be structures which are not parallelograms, but also have equal side length. I guess you can text me on Discord if you have my Discord. Or if you're a TLE student, you can make a doubt as well. Yeah, okay, Akshit, I think I figured out the problem for your the problem in your solution. See, I can have a shape like this, and the length over here is 5, and the length over here is 5, right? But it's not a parallelogram. So your idea will overcount. Okay. What is the logic for intercept? Is simply the formula for intercept. Like take the line equation of line, right? And if you write points, not exactly point slope form, but yeah, if you just write it like y equals mx plus c, right? So if we write it as y equals p by q, x plus c, now you simplify this equation, you get qy equals px plus qc. Okay. Now we again simplify this, we get qy minus px equals c. Now we get the intercept as qy minus px divided by q. Okay. Now the interesting part is here this is a fraction, right? And we don't want to store fractions. But the thing is, since P by Q are already in the smallest terms, P by Q are already in the smallest terms, for the same reason, in midpoint when we had x plus y by 2, we just ignored the 2, right? We just ignored the 2. Similarly, we can simply just ignore this Q over here. We can simply ignore the Q term. So we can get CS QY minus PX because we just need to know if they're equal or not. We don't need the exact value of intercept. So that's why this formula for the intercept we get. And that's exactly what I've implemented. What is Q? Q is the denominator of our slope and P is the numerator. Since we're storing it as a pair of numerator-denominator form, right? So as long as we ignore the denominator, since the denominator for some given slope will always be the same, right? So we can just ignore this term and we can write the intercept like this. Okay? So that's how you derive the intercept formula. Okay, Akshit, you're checking for same slopes as well. Hmm. Okay, then ideally, are you making sure that they are non-degenerate? Okay, yeah, obviously it will not be degenerate because otherwise the points would be same. Okay, you can text me on Discord if you have doubts or if you have my Discord. I think I'm not quite sure why your logic doesn't work. Okay, then any other doubts or general doubts? I would say problem D was the hard one. ABC was quite doable in this contest. D was mostly implementation. If you knew the geometry ideas, the idea would be easy enough, but implementation was there, decent amount. Okay, then, since there seem to be not more doubts and we have discussed all the problems, let's end the session now. Thank you everyone for attending. Hope you learned something. See you in the next PCD. Bye bye.